I'm Joshua Bardwell, and you're going to learn something today about a new technology from ISDT called BattGo. BattGo makes your mini quad batteries smarter. It lets them keep track of if they've ever been mistreated, and it lets them talk to the charger so they can tell the charger how they'd like to be treated. I'm going to show you how this technology works. We're going to take apart a BattGo battery and actually look at how it's different on the inside from your typical battery. And I'm going to tell you whether I think BattGo is going to be the next big thing or if it has a fatal flaw. Stay tuned. What you're looking at right now is a BattGo-enabled smart battery by Charsoon. BattGo is the name of the technology that ISDT invented that we're going to be talking about today. And what makes BattGo batteries different from the dumb batteries that the rest of us are using is that they've got some extra sensors and some extra memory and processing, actually probably a little microprocessor in there even, that lets them record information about their status and communicate that information to a charger or computer via the XT60. So if we look at the XT60 here, we can see that there's actually an extra little pin right here, and that pin goes via an extra little wire here into the battery where the microprocessor is right here on the top of the battery, and it can communicate with the charger via this pin and tell it things about itself. What kind of things does it tell the charger about itself? Well, let's take a look. I'll show you. In order to read that information, you need a BattGo-capable device. And we've got here the BG8S. The T8 will also work, and so will several other ISDT chargers. If we plug the battery into the BG8S, immediately you'll see something different from what you would normally expect. You can see here that we're getting the individual cell voltages, even though we have not plugged in the balance port. See, we haven't plugged it in yet. And the reason for that is that the smart battery tracks the individual cell voltages and can communicate them digitally to the charger or to the battery checker without having to actually make the battery checker measure them. We can see here that the battery is reporting its temperature, so it's got a temperature sensor built in of 28 degrees Celsius. If I go and I hold down the button here, we get to the BattGo menu on the BG8S. And here's where we can see some of the other things about the battery. So we can see here the battery has stored its desired charge voltage of 4.2 volts, its desired charge current of 3.2 amps, and its desired storage voltage of 3.8 volts. Now this is a 1300 milliamp hour battery, and it came from the factory with a desired charge current of 3.2 amps. Now for me, I think that's, what is that, 3S? That feels a little aggressive to me. So what I can do is I can go up, I can change that. Let's just go with, well, I'm pretty conservative. I usually charge at 1S, but I'll go up to 2S if I'm in a little bit of a hurry. So let's just set this to 2.6 amps. There we go. And the battery will now remember that its desired charge voltage or current is 2.6 amps. If we then plug the battery into the ISDT T8 Charger, what you'll see is that 2.6 amps is already set as my charge current, and 4.2 volts is already set as my stop voltage. I could, of course, change that to 4.15 volts if I wanted to maybe not quite fully charge the battery, or maybe it'll even let you set it to 4.25 volts if you want to overcharge the battery, if you're living on the edge. But it already knows what those numbers are supposed to be because you told it. Now the ISDT T8 also has a BattGo menu, which you can access right here. Here's the BattGo menu. Very much the same as the battery checker, as the the BG8S. The next thing I want to show you is the exception record for the battery. Now these are this battery has no exception. That's good, right? That means this battery has had no over voltage, under voltage, over temp events. That's very good. This is a healthy battery. I've got another battery here with a few exceptions. So here we can see that this battery has had over voltage on cells, I think that means it's on cells 2 and 3, and under voltage on cells 1, 2, 3, and 4. And it's had a temperature event as well. Does that mean that the temperature was too low? I'm actually not 100% sure how to interpret these symbols, but we've got some exceptions here. The battery has been overcharged and over discharged is what the battery is telling us. Another feature that we'll mention that's pretty cool is the auto storage feature. What this means is that if the battery is left charged after a certain amount of time, it'll automatically put itself into storage. Leaving your batteries fully charged for too long reduces their capacity. There's a test from the guys at LiPobench.com where they left a battery fully charged for, I think it was 30 days, and it lost something like 5% of its performance, that's not nothing. So leaving your batteries fully charged for too long is bad, and in this case, the smart battery will automatically put itself into storage mode. So we can go here, and you can go from 240 hours, which is 10 days, all the way down to 12 hours. Just how long will the battery wait before it puts itself into storage? Now, at this point, some of you out there are going, Josh, you are so naive. This has been around forever. ISDT didn't invent this. Reeve Electrics has had a technology like this for quite a while now. And the way the Reeve Electrics technology works is you put a smart tag on your battery, basically an NFC tag if you know what that is, and the charger has an NFC reader. And when you go to charge, you touch the NFC tag on the battery against the reader, and the charger identifies information about the battery. And I actually don't know a whole lot about that tech, but my understanding of how it works is that the NFC tag is used to identify the battery, and then the charger knows things about that battery, like how many cycles it has had and so forth. And you can store information about the battery in the charger. But the difference, at least if my understanding of the Reeve Electrics technology is correct, which it may not be, in which case I apologize, but my understanding is that the BattGo technology is better because the BattGo technology stores the information about the battery in the battery. So no matter what BattGo-capable charger you use, it'll all work correctly. The charger will read the information from the battery out of the battery. And if the battery itself, I don't think the Reeve Electrics technology can do things like store over temperature information or cell information, because it doesn't have those sensors built in. The battery is just a regular battery with an NFC tag stuck to it to identify the battery. So in that sense, I think the BattGo technology is better than what Reeve Electrics has got. The flip side, though, is that the Reeve Electrics technology you could just get one of these stickers and put it on any battery you've got, and then your Reeve Electrics charger will be able to treat that battery as it needs to be treated. Whereas the BattGo technology requires, as we're going to see when we disassemble the battery, we're going to take one of these batteries apart. As we'll see, it requires this technology to be built into the battery. And that takes us the downside of BattGo, and there are a few downsides of BattGo, one of which I think is actually like just a total deal breaker. Before we continue with the video, I would like to take 30 seconds of your time to give you a message from the sponsors, which are you, really, my patrons, and the guys who watch the video with the ad blocker turned off. I love making these videos for you. I hope you find them educational, maybe even entertaining. If you do, I'd like to remind you that I have a Patreon, and also I have product links down in the video description. Even if you choose not to buy the exact products in this video, clicking on any of those affiliate links before you make any purchases will give me affiliate income from them. So anytime you're making a purchase from any of my affiliated vendors like Banggood, GetFPV, Ready Made RC, and of course Amazon.com are the big ones, click on any of the affiliate links in the video description or over at fpvknowitall.com, and you'll help me out. It'll cost you nothing. Or become a patron. It'll cost you something, but what's a couple bucks? Okay, on with the video. Just a total deal breaker. So one of the downsides of BattGo is that the manufacturers have to buy into this, and ISDT has not made this an open standard. In fact, in order to put BattGo in your batteries, you have to go sign a contract with. That's my understanding of how it works. That's what people have told me. Obviously, I haven't done it. So what that means is that somebody like Tattoo has to go to ISDT and say, "Oh, ISDT, can we have your technology?" And ISDT is like, "Oh yes, sure." And how does that look? It adds cost. You have to add additional smarts and sensors to the battery. It adds complexity. There's additional, as we'll see when we take it apart, there's additional stuff in here. So it's difficult to know how widely this is going to be adopted. Another downside is that the BattGo technology only works with a BattGo-capable charger. Sort of goes without saying. You can charge the batteries on any charger you want, but if you want to do the super smart BattGo stuff, you have to have a BattGo charger. And of course, ISDT makes the only BattGo-capable chargers on the market right now. It's possible that they will license that technology to other manufacturers, but again, it's hard to imagine somebody like, like iCharger going to ISDT and going, oh, can we have your BattGo technology, please? I just feel like, if anything, Pride would, they just invent their own technology and compete with ISDT, right? So you're kind of locked into an ISDT charger. I don't think that's necessarily a bad thing, because I think ISDT makes pretty good freaking chargers, but a lot of people don't agree with that assessment. Let me show you another downside of the BattGo technology. I'm going to plug the balance lead here into this chart, into this BG8S checker, and we can see that it's reporting 3.7, 3.774, 776, about 3.77 volts, roughly, on each one. And notice also that this fancy schmancy charger is reporting down to the 1/1000th of a volt. Is it accurate? I got something coming in the mail that's going to test the accuracy of this thing, but that's for another video. So we're at right about 3.77 volts. Okay, now I'm going to plug just the XT60 in, and you're going to see the cell voltages again, but this time they're going to be reported by the BattGo sensors inside the battery. .81. It's a pretty big freaking difference. So the BattGo sensors inside the battery may not be accurate, and as far as I know, there's no way to calibrate them. Maybe there is, and I just haven't found it. It's not terribly well documented. So, and that's why this battery has the exceptions. You remember it? This is the battery that had the overvoltage exceptions. Well, it's never had an overvoltage. It just got charged to 4.2 volts per cell, but the internal sensors are miscalibrated, and so it thinks it's been overcharged to 4.22 volts per cell, or whatever the difference is. As far as I know, there's nothing you can do about that. But the real reason why I don't think BattGo, at least in its current form, I don't think it's going to go anywhere in the mini quad market is this. It's a parallel charge board. In fact, it's my parallel charge board. And what is it missing that the battery has? Look at the XT60. It doesn't have that little pin that lets the battery talk to the charger. And in fact, if I plug in a bunch of these batteries to the parallel charge board, how would that even freaking work? Like, which one is the charger going to talk to? You're going to have to invent some kind of networking protocol and a smart parallel charge. I don't even know how it would work, and it doesn't work. And that's why I think BattGo is not going anywhere with mini quad pilots, because we have lots of small batteries, and the only effective way to charge lots of small batteries is parallel charging, in my opinion, and the only way to do it in a reasonable amount of time anyway. And parallel charging just breaks BattGo. It just doesn't work. BattGo requires that you plug the battery directly into the charger, and I just don't do that very much, and neither do many people. Now, if you absolutely refuse to parallel charge, then maybe that objection goes away. But there still were other objections that I raised, not widely implemented, and sometimes inaccurate. And so I feel like BattGo falls in the area of a really clever and cool idea that I wish were slightly better. They're just kind of fatally flawed at this point. But I have confidence that ISDT is not going to let this lie. They consistently seem to innovate and develop, and I hope that they take these criticisms to heart and come up with some awesome, cool way to make it work even better. But we're not done with the video yet. I said I was going to take the battery apart and see what was inside it, and I think you guys would all love to see me tear a LiPo apart and light my hair on fire, and we're not going to do that. So let's do that part, and that'll be how we'll close out the video. In fact, when I got these batteries from Banggood, and by the way, Banggood sent me these. I asked for them, and they graciously sent me the batteries. I said, send me some extras because I'm going to tear them apart. So let's see if I can get in here, and we'll see what these batteries are made of. Where's my fire extinguisher? My bucket of sand. First thing I'm going to do is take off the outer cover. I should do the one that had the exceptions, right? Except it didn't really have exceptions. It was never overcharged. It was just miscalibrated. I've got this tape around here. It's just like electrical tape, basically. And this is all pretty standard. except you can see we've got something extra up here, and that probably is the circuitry. I'm going to be real careful at this point. You don't want to go sticking anything metal in here, because this is where the tabs are at the top of the battery, and if you short that, you'll have a bad day. Should really have discharged these batteries before I did this. Some tape around the outside. And here is the padded tape on the top. This is all pretty standard battery construction. And we've got this extra wire which has been retained underneath this layer of tape. It's nice. So that's the digital communication wire. Again, be real careful if you ever do this, not to accidentally short this with your tool. Okay, and here is part of the magic. Now that is not going to easily come off. It's soldered directly to the XT60 and soldered directly to the tabs on the cells. So it's going to require some work to get that off without deforming the cells. I don't want to do that. You can see there are individual wires from the individual cells going here into the BattGo device, this brain, if you will. That's how it measures the cell voltage. And there's this board right here, and it is, so it's got pins here and is soldered on. It's got very nice that they've done this. It's got this extra tape or padding here to help keep it from, I guess, moving around. One of the reasons I wanted to take this apart was that I wanted to see if the temperature sensor was installed down in the middle of the pack in between the cells. Measuring the temperature of a battery on the exterior actually doesn't tell you what the most important thing. The battery is much hotter on the very inside, and I've heard as much as like 15 degrees Celsius. Some people who have actually measured the difference have told me. So I don't see any evidence of that being the case. The cells it just looks like a standard pack with nothing in between there. So I'm going to guess that the temperature sensor is here on the board, and that's actually really it's not even really physically in contact with the pack. Let me see. If there was a temperature sensor on the inside, there would have to be a wire coming from it, wouldn't there? I don't see any evidence of that. These wires here are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, these wires here are the sensor wires for the individual cell voltages, and this is the output wire for the communication to the XT60. So no, I'm going to guess that there's just a built-in sensor on board. And so even the temperature sensing is not the best, because it's not even really physically in contact with the cells. It's just kind of nearby to the cells, as near as I can tell. And I could go and I tear this apart, but I don't think that I will. I don't think that there's really any evidence that I'm going to learn anything new by doing that. So there you go. Pull those cells apart. That's always a little bit risky. So BattGo, final conclusions. It's a really cool idea that nobody really has implemented except Charsoon. Anybody want to fly Charsoon batteries? Give up your tattoos, your thunder powers? And yeah, no, I didn't think so. So nobody's really implemented it. No sign that they ever will. And even if they did, it's got some fatal flaws. Like it doesn't really work with parallel charging at all. So there you go. My policy is usually that if there's an obscure thing that you probably never heard of and it's also kind of not very good, then I don't even bother telling. Why waste your time, right? But I really wanted to dig into BattGo and learn if it lived up to its promise or not. And I know that some of you also felt the same way. So now we know And that's going to do it for this video. Leave any questions or anything you think I overlooked down in the comments. Thanks for watching. Happy flying.